Hello, good morning. My name is Mr. Wanjala, the Star of Excellence. Welcome to our tutorial today. Today we are interested in learning about equations of straight lines, and specifically we are going to talk about perpendicular lines. So first of all, we check on the relationship of perpendicular lines. You can be able to see that perpendicular lines have such relationships among many. We have the first one here is they have or they intersect at 90 degrees. They intersect at that point of intersection where the two lines intersect is 90 degrees when you measure. Then the product of their gradient is -1. When you multiply the gradient of the first line and the second line, you will get -1 as the product. So therefore, that relationship, those two relationships can be able to lead us through finding the equation of one line when you have been given another line. That is what we want to talk about today. Check, for instance, this consideration here. We consider this example that we have here. We have been given, and it says, a line L1 whose equation is given as 2y is equal to 3x plus 4 is perpendicular to another line L2 passing through a point Q 4, 9. That is 9. Find the equation of L2 in the form AY is equal to BX plus C. This instruction is given so that you don't just leave the line in the form of y is equal to mx. From the previous tutorial, you remember we said that equations of straight lines are given in the form y is equal to mx plus c. Therefore, when we get that, we are going to rewrite the equation in this particular form that we have been given here. Ay is equal to bx plus c. Good. Let's get to business and see how we can be able to find the equation of L2. Why? Because we have been given the equation of L1. We are going to get the gradient of L2 from the gradient of L1. And that is through the relation, the second relationship, that is the product of their gradient is -1. Let's go. Solution. Given, what have we been given? We have been given equation of L1 as 2y is equal to 3x plus 4. Then we have also been given the point Q, that is 4, 9, for the line 2. Good. That information is enough to start working out and finding the equation of line L2. Good. Necessary enough, we can be able to start from finding the equation of, we can start by finding the gradient of line L1, because that is the most important thing that we need before we find the equation of L2. You cannot be able to find the equation if you do not have the gradient. That is the most important thing that we are supposed to note. And therefore, if we get the gradient of L1 using the relationship that we have here, m1 multiplied by m2 is equal to -1, that will give us the gradient of line L2. And using this point here, the point Q here, you are together with the gradient that we will have gotten, then we will be able to get the equation. Good. So we rewrite the equation of line 1. This equation is 2y is equal to 3x plus 4. How can we rewrite this one so that we get the relationship? Because why do we write the equation of a straight line in the form y is equal to mx plus c? We write it in that form so that we may have y is equal to, you see this, y is equal to mx plus c. This m here is the gradient of that particular line. And this c here, this c that we have here, is a point where the line intersects with the y-axis. We call it the y-intercept. We call that the y-intercept. And therefore, we have to rewrite this particular equation in the form y is equal to mx plus c so that we get this m. When we get that m, then that m will be our gradient. Good. So here we have rewritten the function in this particular manner. Y is equal to 3 over 2, basically by dividing every particular point here by -2. So you have -2, -2, -2. So you see, we'll have these 2 and that 2 dividing everything on the other side of the equation. So we have 3 over 2, then plus 4 over 2, which is what? Which is 2. That is necessary. So important enough, then that one, we can get the gradient. See this one here, we can get the gradient, that particular gradient, which is m. And that m is this one here that we have. That is 3 over 2. So that is what we have here. You see that now we have the gradient. So to get the gradient of the second line, then we have to get the function. You remember this relationship? The relationship is this one here. The product of their gradient is -1. Good. So the product m1 multiplied by m2 is equal to -1. So that will give us the gradient of m2. Good. So when you multiply that, then you're going to have m1. Our m1 is 3 over 2. m1 is 3 over 2. Multiplied by m2, which is the gradient of the second line, it will be equal to -1. You just solve that one properly and you will have -2 over 3, this one, -2 over 3 as the gradient of the second line. Good. So after getting that particular gradient, therefore, we can be able to relate what we did yesterday. We said that we have been given a point, and that point is Q. The point Q9, 49 is the point we have been given. And you remember we said that all the points on that particular straight lines, when you compare the gradients of any 2 points, that particular point, the gradients of that line is equal. So you only need 2 points on that line to find the gradient of that particular line. So when you have 1.49, we need another point xy, and we find the gradient, and that gradient should be equal to the gradient we have here, -2 over 3. Good. So that will be y minus 9. We have that y minus 9 and divided by x minus 4 is equal to the gradient that we have, -2 over 3. That one now have 3. You just cross multiply, remember, just cross multiply. Then when you solve that one, you solve this particular problem here, you'll end up with 3y is equal to -2x plus 35. You see that? We multiply, you open this bracket, 3y minus 27 is equal to -2. Multiply this, you have -2x, then negative gives you a positive, then you have +8. Then here now, you just work out. You remember what you are doing. You subtract, you add 27 on this side so that we eliminate the 27 on this side and bring it on this side. So we are going to add it on this side. When you add, you have 35. So this equation is 3y is equal to -2x plus 35. Remember, we have written it in this manner because the instruction said find the equation of L2 in the form ay is equal to bx plus c. Therefore, our a is 3, our b is -2, and our c is 35. That is how we find the equation of perpendicular lines. What you are supposed to note is that the equation of L2 and the equation of L1, all of them will depend on the what? On the product of their gradient being equal to -1. So the perpendicular lines have this particular important information that you are supposed to note. They intersect at 90 degrees. The product of their gradient is -1. Very important for us. Thank you so much. for watching, and meet me again in the next tutorial. This is the Star of Excellence, Mr. Wanchala. Thank you so much.